Today we're going to be talking about section 11.2. We're actually going to do two different lessons with this section. So the first one, because there's two different tests we can work through. The first is called the chi-square test for independence. Okay, when we're testing for independence, we're testing to see if two variables are related to each other or not. Okay, so if I were you guys, I'd make that note up top. We're testing to see are two variables related to each other or not. The amount of exercise and your muscle mass, are those two variables related or not? Your amount of studying and your IQ, or your grade in the class. You know, did you pass, did you fail, and how much did you study or not? Those kinds of things, are they related? Here's another example. Suppose a new post-operative procedure is administered to a number of patients from a large hospital. One can ask the question, do doctors feel differently about this procedure from nurses, or do they feel the same? Okay, so I made a note. This is about the difference in proportions between the two groups. So it's not whether they prefer the procedure or not. So it's saying, like, nurses, doctors, is this proportion of they prefer the new procedure the same as this proportion, the same as this proportion? Do these proportionally basically break down to be the same thing? All right. When we work on these are always going to be set up in a two-way table, which means that we have at least 2 rows and 2 columns of data. Okay, unlike this example that we had the other day, this was in a table, but it was only 1 row. So if you only have 1 row of data, it can't be a test for independence, because a test for independence has to be at least a two-way table. What we need to make sure we are careful of is our rows by columns, okay? There's 2 rows, there's 1, 2, 3 columns. Your degrees of freedom come from rows minus 1 times columns minus 1. So for this problem, we would have 2 rows and 3 columns. So that's a minus. So we'd get 1 times 2, and our degrees of freedom would be 2 for this problem. Okay. When you work through, you're going to have a couple things. So the first is you're going to state your hypotheses in the context of the problem. So you're going to go through and you're going to say, like, the two variables, identify them, right? So nurse, doctor, and how they feel about the procedure are independent from each other. You can also use the phrase not related, because independent means they're not related. Your alternate is always going to be the two variables in the context of the problem are dependent, or you could say they are related. Okay, so you could say preference about the procedure and the occupation are related to each other, or they're dependent on each other. Okay, now what happens is we're still going to have the same formula here. Chi squared equals O minus E squared over E, the sum of. So we still have the same exact formula, and it's still going to have a right-tailed test. We're still going to be using chi-squared CDF. The numbers in the table are your observed, but we need to find the expected. And this process is how you would find the expected. Okay, so the first thing we want is we're going to come up with the totals. So this is a 150 total, this is a 200 total, this is a 50 total, which means the grand total is 400. Okay, if you add up this row, it's 200. If you add up this row, it's 200. They just happen to both be 200. Okay, and what we would need to do, since there are 6 cells in this table, that means that there needs to be 6 fractions when you do this formula. So I want to show you how to calculate. So I'm going to calculate the expected value for this with the star. Okay, so your expected value with the star, if I put it here, your star's expected is going to be the row sum. The sum of this row is 200. The column sum is 150. And the grand total, sorry, I'm writing off the screen. The grand total, so the row sum was 200. The column sum was 150. And the grand total is 400. When you divide that down, you get 75. Okay, you would do that. So the observed for this one is 100. The expected is 75. You would do that again here, again here, again here, here, and here. Okay, so you would do 6 expected values. Then you would do the fraction six times and add them all up to get your chi-squared value. But what I'm going to show you guys is we can actually skip this part and we can get this in the Inspire. Because I'm sure you were just like, there's no way I'm doing all that, Miss McMichael, that's ridiculous, right? And that's okay, I feel the same way. Like, that's just a lot of busy work. A lot of busy work that's computation, like, come on, right? We can use our technology wiser for us. So what we've got is we've got our steps up here, and I'm gonna walk you through these in a few minutes when I am working on this problem, okay? So the first thing we want to do is we want to talk about this problem here. A sociologist wishes to see whether the number of years of college a person has completed is related to where they live, right? So urban, suburban, rural, how much college they've completed, are they related or not, okay? And it's one of those things, right? Like my parents live in, my parents are in the same house, and my dad has a high school diploma, and my mom has a bachelor's and an MBA, right? So they're two different categories in the same house, right? So they're in the same thing. But maybe it is related, maybe it's not, right? It's not a perfect science, but is there a general pattern? All right, and it's telling us that there's a sample of 88 people here. So we want to first write out our hypotheses. Remember, the first one is, like, your null hypothesis is the two variables are independent. Okay, and we can see right here, can the sociologist conclude that a person's location is dependent on the number of years of college, or are they related to each other? So I'm going to have a person's residence location and number of years of college are independent. All right, you have to write it out nicely the first time, like thoroughly. And then for your alternate, I'm okay if you say a person's residence location and number of years of college are dependent. And you can just use the quotes to accomplish that. Okay, step 2. Instead of doing, notice this has 9 cells. So you would need to do that expected value formula 9 times, then do the formula where you add up all the fractions with 9 fractions. Okay, so instead, I'm going to walk you through these steps. All right, so you're going to open a calculator screen. You're going to hit menu. You're going to hit number 7, matrix. Okay, you're going to hit number 1, create a matrix. And you're going to pick number 1, matrix. All right, this matrix is a 3 by 3, 3 rows, 3 columns. So I have 3, oops, not 23, 3, tab, back it up, 3, tab, press OK. All right, you're going to type in the numbers. So I'm going to type in my 15, tab, 12, tab, 8, tab, 8, tab, 15, tab, 9, 6, 8, 7. Here's the key. All right, now what you need to do is, see how it's saying fill in the matrix, but don't press enter yet. You need to go to the right, so your cursor is outside the matrix. Then you need to hit Control var. There's an arrow, and you need to call it something. I always call it A. So I always call my matrix A, and then the next matrix, when I call that matrix A, it erases the old A that I just had. So that's the system I use. If you want to type in a word, you can, but then in a minute, you need to type in that word again. So I'm going to press A, and then I'm going to press enter. And it's going to look like nothing happened. But what has happened is I've now stored, see how it says Control var is store, S-T-O? I've stored matrix A as this in my calculator. All right, now what we're going to do is we're going to move on to number 2. We're going to press menu, number 6, statistics, number 7, stat tests, and then you're going to go down to number 8, a chi-squared two-way test. Okay, and here, this observed matrix is whatever you just called your matrix. I called mine A. If you typed in a word, you have to type in that word again. Okay, so A is just simple. And you press enter. Enter, there we go. What happened is the calculator just did like all the number crunching for you. Okay, it found all 9 expected values, did the big fraction with all the addition and all 9 fractions, added them up. It's right here where it says chi-squared This 3.055 is your answer. It did the whole formula for you. So whatever notes you want to take on your paper, okay, step 2, your formula answer is already done. It's chi-squared equals 3.0055. Okay, now it also gives you your p-value. Okay, so it gives us our step 3. When you're writing this down, since we're having the calculator do all this heavy lifting, right? Oops, I didn't mean to put an extra 0.5569. Okay, and the degrees of freedom were 4. We got the degrees of freedom by doing rows minus 1 times columns minus 1. 2 times 2 is the 4. Okay, what we need to do, since the calculator is doing this for us, is we need to also write down our expected matrix. The calculator will give it back to us. Okay, so our expected matrix, in order to do that, what we're going to do is we're going to follow these steps. We're going to press var, and then it's going to be here, stat, oh, sugar, this guy, stat.expected matrix. Okay, so that's the button we need to pick. So you're going to go to that one and you're going to press enter, and then you're going to press enter again, and here's our expected matrix. You can go up to like scroll through to read them, okay? It's giving you the long decimals, and what you need to do is you need to write them down. At the very least, you can write these down, right? We didn't have to do these all by hand in such an obnoxious fashion, right, of that computational stuff. So at the very least, we can jot this stuff down, 8.7 and 5.7, okay? So the observed was 15, we expected 11.5. The observed was 8, its expected was 10.5. The observed was 6, we expected 6.9. All right, so now we're going to do our comparison, right? P-value, alpha was 0.05, p-value 0.5569, definitely greater. We're going to do not reject, then null. Okay, which means what? We can really just rewrite the sentence. A person's residence, location, and number of years of college are independent. They're not related to each other. Like I said with my mom and dad, right? Same house, same location, completely different academic backgrounds. Alrighty, so we've got that p-value, do not reject. Okay, and you'd write the same, your HO, a person's residence, location, and number of years of college are independent. So, what I'd like you guys to do, because these are going to go kind of quick, right, is I want you to make sure you're practicing the calculator stuff. All right, so as you're looking through, a researcher wishes to determine whether there's a relationship between gender and the amount of soda they consume. All right, this chi-squared type of test is used so often in the real world in data analysis. Are the two variables related to each other? We don't have ordered pairs, so it's not a scatter plot like we did back in October and November, but it is really important, right? Like to determine if things are related. So we're going to start by writing out our hypotheses, okay? So you should have your null hypothesis, soda consumption and gender are independent, or they're not related to each other. Your alternate would be that soda consumption and gender are dependent, or they are related to each other. We're going to go into our calculator. All right, you need to memorize these steps, guys. I mean, yes, I know it's open notes this year, but college is not going to be. If you take another one of these, you got to be really fluid and familiar. And remember that speed thing, the more you practice, the easier it gets. Okay, so we're going to create a matrix. We're going to go menu, matrix number 7, number 1, create, number 1, a matrix. Okay, we have 2 rows and we have 3 columns. We're going to type in our numbers, 10, tab, 9, tab, 8, tab, 13, 16, 12. You're going to go to the right and you're going to hit Control var and you're going to store it as A. I just pick A every time and then it erases the old A. Enter. Okay, then we go menu, stats, number 6, 7, stat tests, and we're going to pick number 8, a chi-squared two-way test. Your observed matrix is A. You press enter, you press enter again. All right, so it's giving us our chi-squared value. It gave us our p-value. Right, it's giving me my degrees of freedom. All right, now we need to find our expected matrix. Here's my expected matrix. I got that by going var and then down to here, stat dot expected matrix. So these are the expected values that we just found. Remember, you can't get the expected matrix till you run the test that we just did. If you don't run the test, you're gonna get the same expected matrix as the previous problem because we haven't redone the problem. Okay, so p-value way larger than alpha, which means do not reject your null, which means we can conclude that soda consumption and gender are not related to each other. Okay, so example 3. Let's go ahead. You guys should be able to do this on your own, okay? At least try it, right? You might need to rewind the video or check your notes. That's fine, but you should be able to try it on your own. The study is conducted as to whether there's a relationship between joggers and the consumption of nutritional supplements. Random sample of 210 subjects is selected. They're classified as shown. So it's like, do you take vitamin supplements and are you a jogger or not? All right, and we're going to see if they're related. So you guys should be able to run through the entire problem. So pause the video right now, run through the problem, and then check your work. This is the bare minimum that you can have. If you put these down and you don't have this, then you're not getting full credit, okay? Because the other way we could do this is we could do it by hand, the whole obnoxious formula, okay? So this is really important that you make sure you do this, okay? Since we reject the null, that means that jogging and nutritional supplements are related or they are dependent, that they depend upon each other, okay? Hold off on this until I specifically tell you in class or Google Classroom to do this assignment. So hold off on the assignment. Hope you took marvelous notes, and then we will finish the rest of this section probably together in class next time I see you. Talk to you soon.